Sorry I spoiled this before. Every time I seem to do examples, at least with the laser pointer, it doesn't skip. So for the next part of it, we're going to be discussing planetary motion. So we're kind of building on sort of the same structure we did in mechanics, but in terms of space, because we started off with our units. Then we did some simple calculations on gravity, and now we're doing things related actually to circular motion in a way. So this man here, Johannes Kepler, uh, a very famous scientist, obviously back in the day, and he's developed these things, the three laws of motion. Now, this isn't a direct copy of Newton's three laws of motion. There just happen to be three laws of planetary motion that this guy found. Um, One other thing is that a lot of his theories um, were mostly just eyeballing. So um, he actually looked and studied the planets and actually just guessed the three laws because, well, obviously he was spending a lot of time observing. And while he was doing that, he just kind of looked and saw a pattern and then just said, well, this is just how it is. This is what I'm seeing, so it must be true. We actually know that his laws are actually true, so he's looking at that side. And he put all of his um, theories, especially the theories of the universe, into a book known as Mysterium Cosmographicum, which if you watch Vsauce, you've probably seen a video on it. But it translates in Latin as Mystery of the Cosmos. Now, his work overall in Mysterium Cosmographicum is that the you could actually scale the planets based on these things known as the Platonic solids, which are the solids that are made up of one polygon and they equally meet at vertices. So, for instance, a cube is made up of all squares, and all of the squares meet three at a corner. So, if you're familiar with the Schläfli symbol, it would look like this, which means four sides per polygon, and then the polygons meet three at a time at each vertex. So that's only one of the Platonic solids. There's actually five. You have the tetrahedron, the cube, the octahedron, the dodecahedron, and then the icosahedron. There's plenty of videos discussing these Platonic solids actually in pretty good detail. I just won't have the time for it, and it wouldn't be actually fit for this course. So at the time, no planets beyond Saturn were actually properly observed. Obviously, now we have Uranus and Neptune to look at, and obviously all the ones beyond that. But Uranus and Neptune weren't actually considered in this time; they were discovered until about the 1800s. And what he found was that um, the Platonic solids actually approximated the spaces in the orbiting of the planets. So when lined up in a specific order, which happened to be octahedron, icosahedron, dodecahedron, tetrahedron, cube, it actually fit that model of the universe. So he imagined that only five Platonic solids were known, but it was theorized at the time that more planets existed. Obviously, this is flawed now because we know there's five Platonic solids and more than five planets in our orbital, as stated here. Now, what did this actually look like? Well, here's a sketch, or sort of a revised sketch of what it was. So the cube on the outside, then on the inside you've got your tetrahedron, then your dodecahedron, then your icosahedron and octahedron would go in there. So that's what actually, or sort of a rendition of what he thought the universe was like, which began to be flawed. But the three laws that we're going to discuss in the next video are actually still all true and completely physically valid.